Oh yes, Sleeping Warrior has created a response to my video where I explored a formulation of classical mechanics with the starting point that the relative density disequilibrium causes a force. Now he asked me to do a response to his response and I agreed to do so if I had time this week. Well, as you are watching, I clearly did have a bit of time to do a thing. Throughout the video, Riley demonstrates buckets of ignorance combined with an astounding amount of arrogance. Now, I won't go through the comments thoroughly, but I would like to highlight a couple of replies that he posted. Firstly, he thinks that I won't respond and address the points that he made. Well, that will happen in this video. Secondly, someone posted this comment. Now, a sensible person would think to themselves, maybe I wonder if there is the possibility that I may have misunderstood something. But no, Anthony Riley takes this approach. But let's have a look at the description of the video.
It's an attempt to debunk the relative density disequilibrium position that I currently actively endorse.
Now, Riley states that I tried to debunk him with the application of pseudoscience. Now, this is the first hint that shows that he hasn't got a clue what he is talking about. I was trying no such thing. I merely tried to explore classical mechanics starting with the assumption that what Anthony Riley is saying is actually correct. So yeah, there's no attempt to debunk you there, mate. I'm just trying to build an internally consistent model.
I've already downloaded and put through the video editor his video. And I've sped things up where necessary, and I've turned the volumes down on stuff where necessary. It's going to turn that one down a little bit more because it's too loud.
Well, yeah, you would have. There are two reasons why you might have done that, and that is that either you don't want to risk your audience actually following the logical flow of the arguments I present because it destroys your little narrative, or you just didn't understand any of it. Now, I'll be generous and assume that you did it because of the latter reason. After all, you think that I tried to debunk your claim, and this demonstrates that you didn't get the most important part of the video. But let's move on.
I have already done this video once, and I realized that I had my gate on too high, and it was cropping out too much of my voice. So I am going to have to keep an eye on the voice side of it. I'm going to open up my voice meter and I'm going to keep an eye on the levels, which is what I did not do first time round, in the attempt of saving me doing this for a third time. Anyway, let's get going. I'll be short, sweet, concise, to the point.
A while ago, I did a video about Sleeping Warrior's little experiment where he thinks that he shows that some relative density disequilibrium creates a force. Now, I remarked that for this to be true, we need a coefficient to make sure that the units work, and a coefficient would need to have units of meters to the fifth power divided by seconds squared. Now, of course, the whole relative density disequilibrium thing is nonsense, but I thought it would be fun to see where this would go if we assumed that it...
We don't need to have a coefficient to see if anything works. I don't know why you have this perception. We don't need coefficients to see if things work. That's not what science is. Science is cause and effect. We'll come back to the definition of science in a moment, but I don't know why you would be citing that we need coefficients when we don't. We just don't. The only reason why you're saying that is to justify you sciencing or mathematizing or Einsteining the shit out of this situation. That's all you're doing. You're justifying your future behavior. We don't need what you're saying here. Coefficients we just do not need.
Well, you do. If you actually watch the video, then you would understand why. And the issue is that regardless of how you formulate it, your relative density disequilibrium nonsense does not have the proper dimensions you need. So you need a coefficient in place to ensure that the problems are dimensionally consistent. Now, this coefficient could just have a magnitude of 1, but for the model to work, you still need it.
Carry on.
were true. Now, what follows is a demonstration of how we approach physics.
What follows is a demonstration of how we approach physics. Listen carefully to what he says here, because what he says is not what physics is. Let's quote the guy verbatim.
We start with a statement and then develop it to create a model, and we then test that model. It's simple as that.
No, we start with a statement, and in my case, relative density disequilibrium. If I change the density of the medium, the egg will move. That was my hypothesis. That's my statement. So we start with a statement. We're all right at that point. But we don't create a model and then test it to see if it works. That's not what we do in science.
That, my friend, is where you go wrong. And if it weren't for this bit of wrongness, I probably wouldn't even bother making this video. What we do in physics is develop a model. This could be a model for how shit falls or the efficiency of an engine. It doesn't really matter. What we then do is fit the model to some data and see how well it fits. If it is a good fit, then that is great, but it doesn't actually prove that the model is correct. It merely shows that it is a less bad model than the others, which don't fit as well. The best model then becomes part of our theory, provided that it gels well with the established theory. But if the best model doesn't work with theory, then either the model is wrong or the theory is wrong. And actually, in this area, it's where physics gets the most interesting. So in essence, actually, a model is just a very rigorously built hypothesis. Your issue with models is that you don't actually want a formal framework in which to operate, because without one, you can spout bullshit all day long without performing a single proper hypothesis test. And no, a hypothesis test is a little bit more complicated than just shrugging and going, yeah, sure, it looks like it, so it must be true.
So let's see what a couple of these definitions are for the benefit of audience here. Science.
The intellectual and practical activity encompassing the systematic study of the structure and behavior of the physical and natural world through observation and experiment. This definition again. Let's see how many of the bits I actually addressed.
The intellectual.
Yep, I covered that. I thought about things.
And practical activity.
Yes, I did a thing.
Encompassing the systematic study and...
Well, I was nothing but thorough, logical, and systematic.
Of the structure and behavior.
Yep, definitely covered that.
Of the physical and natural world.
Yes, that was the subject matter.
Through observation.
Yes, the observation that a change in density did a thing, which is incorrect, by the way.
And experiment.
Holy shit, I even did that.
There's a lot of ands in there. You've got to do a lot to qualify for science. Notice that it doesn't say anything about making any models.
Well, have you considered this word?
That's a problem if you're going to claim that doing science or physics involves making a statement and then modeling it and then testing the model, because that's not science. It's not physics either, which we'll come to in a sec. But let's just be clear, this guy said talking about making models, and I'm going to say this is complete and utter rubbish. Next statement here that is pertinent here. Definition for pseudoscience. I use this all the time. Pseudoscience, a collection of beliefs or practices mistakenly regarded as being based on scientific method.
So what you do then?
Well, this is clearly a practice, and it is definitely not being based on scientific method. It's being based on a model. By definition, if it is based on a model rather than based on scientific method, it clearly satisfies the definition for pseudoscience, which is what my friend here is clearly practicing. Next one, he did mention the word physics, so let's consider the meaning of the word physics. Just type it in Google, see what it comes up with. The branch of science concerned with the nature and properties of matter and energy. The subject matter of physics includes mechanics, heat, light and other radiation, sound, electricity, magnetism and the structure of atoms.
No, I am not arguing with that, but all we have shown is the domain with which physics concerns itself. You see, all the other bits are too complicated to express in simplistic physics terms. However, this definition does not say anything about methods.
Doesn't mention anything about modelling stuff, does it? Modelling is modelling. Modelling is not physics. Physics is not modelling. There is no part of physics that has models. You can test models for predictability purposes, but they are not part of physics. They are part of forecasting or modelling, but they are not physics.
Well, yes. Please point out at which point I claim that what I'm saying is even remotely close to a scientific theory. It is a model. It is all based on the assumption that you are right about the relative density disequilibrium. And guess what? I test the model for its usefulness as a predictive tool.
What I did find was this particular definition, which our friend should be aware of: reification. It's a fallacy of ambiguity when an abstraction, in this case a hypothetical construct that he's referring to as model, is treated as if it were a real concrete event or a physical entity. He's about to demonstrate to his stupid audience, his dumbass audience, that he can create a model that doesn't purport to reality, and then he's going to pin it on me because his own model doesn't work.
Now, this one is brilliant. I love how he pulls this one up because this clearly demonstrates his inability to read past the first 3 sentences of any article. Now, I did ask him if he read the whole article. Which is funny because if you scroll down a bit, then you'll find this paragraph. The degree to which a construct is useful and accepted in the scientific community depends on empirical research that has demonstrated that a scientific construct has construct validity, especially predictive validity. Thus, if properly understood and empirically corroborated, the reification fallacy applied to the scientific construct is not a fallacy at all. It is one part of a theory creation and evaluation in normal science. Just properly read your sources for once.
Does that mean that he's demonstrated that I'm wrong, or does he just demonstrate that his own model's wrong? But basing it all on your model is logically fallacious. It is a fallacious reasoning position. It's circular. A common case of reification is the confusion of a model with reality. This is what my friend is about to do.
And also there's a key bit that you've missed, and that is that I am not asserting that the model is correct or a reflection of reality, let alone reality itself. But of course, I don't expect Sleeping Warrior to appreciate nuance.
I have had the privilege of watching this video first, that's why I've annotated it all. The guy's a moron. He's part of the problem, he's not science, he is part of the antithesis of science. And that's the reason why I'm here pointing this out to my audience. Now, whether you accept that or not is entirely up to you, but now let's listen to what the guy says.
Now, I will try to develop a model which is internally consistent and holds with other laws of physics, namely
an internally consistent model that holds with other laws of physics, namely whatever he's about to say. It's going to be reification, because models are not physics, sir. Why you would present yourself as physics, I do not know, but you are clearly fallacious. You are reifying a model as reality. That is wrong. Not science, not physics. Pseudoscience. That's what it literally is.
The conservation of energy, momentum, and therefore kinematics. Now, when we look at words relative density disequilibrium, we conclude that he means to say that forces are caused by a difference in density. An object in a medium moves to a point where the difference in the object's density and the surrounding medium's density is the smallest.
Why don't you quote me verbatim with what I actually said? You should be quoting me verbatim. I said, if I manipulate the medium, I will force the egg to move. That's what I said. I didn't say what you just said. Whether that's true or not is irrelevant, but you should be citing my position. If I change the medium or the density of the object in question, I can force a displacement. I am working within scientific method. I am conforming or confirming science. That's what you should be saying. What you've just said there is not my position. May be accurate, may not be accurate, but it's not my position. You just made that shit up.
I see that you still have issues with understanding things. I am not trying to debunk you. I am not trying to strawman you. I am merely trying to develop your ideas further. My formulation of your relative density disequilibrium is, as far as I can see, the only formulation which makes sense.
Go with this bit now. I think I've sped this bit up. Yeah, I've sped this bit up. I've turned the volume down because basically he's Einsteining the shit out of this.
Well, if you actually understood what I'm saying, then you would realize that I'm formulating a model based on your ideas. In this video, I'm not disputing you. I'm merely exploring your ideas.
With a load of mathematics, and the purpose of it is to make a really presentable and verifiable and credible counter to my position, which I demonstrated with the egg, and I showed that if I changed the medium, the egg would displace.
No, this is not counter to your position. It is building on it.
It's that simple. The more this guy goes on about mathematics, he's literally trying to bamboozle his own audience with maths.
You see, I don't bamboozle, I use mathematics, but if you properly showed the opening screen to my video, then you would realize that I put a very big disclaimer saying that if maths is not your thing, then this video is probably not for you. If I tried to bamboozle my audience, then I would not have shown the full derivation of the expressions that I used. You see, unlike most flat earthers, I adhere to a very important concept in science, and this is transparency. Even though it is at the cost of narrative, I will never compromise on completeness and do my best to make sure that all the steps are very clear. This is called having respect for your audience. On which note, where is the data from your experiments?
The problem is he's reifying his own model, and he's basically practicing pseudoscience.
No, this is not my model. Okay, I developed it, but it is the inevitable consequence of your conclusion, and it has fuck all to do with the model I actually work with in my day-to-day job. And at no point do I treat the model as if it were reality, so no reification there.
Now, at the end of the day, some people would argue that there is valid, credible maths in here. There may well be. I'm not a mathematician.
Yeah, that's pretty clear, because if you were, then you would realize that I'm not trying to debunk you.
I'm practicing science. Science is a cause and an effect relationship. It's an experiment where you either validate your hypothesis or your null hypothesis, but you will invalidate and reject the other. So if you accept your alternative hypothesis, you will invalidate your null hypothesis, and alternatively the opposite way around too.
Yeah, this is not quite right, but the general spirit is there, so I'll let you get away with this, as I don't really give a fuck about semantics.
You don't need any maths in science. You don't need maths at all. Why? Because maths is a science is a cause and an effect relationship. No room for maths in science.
Hold on. I thought that you need science to be repeatable and quantifiable. How can you quantify something without using maths?
Yeah, you can use it as a predictive tool if you want to, but what if you make a prediction and it turns out to be wrong?
Oh, my dear chum, that is a beautiful statement. Indeed. What if you make a prediction and it turns out to be wrong? Well, this is truly where cutting-edge science lives. We can use all the maths we want, but if it doesn't agree with reality, then there's something funny going on. And this is the interesting bit. Provided that your maths is sound and your experiment is well performed, they should agree. If they don't, then something is wrong. Now, usually this means that the experiment is wrong, but sometimes the theory is wrong, and this is every physicist's dream. But as you are not a mathematician, by your own admission, how do you know if your experiments are consistent with the current theory? Because I assure you that your egg experiment and your magnesium experiments are actually all consistent with established scientific theory without your relative density disequilibrium nonsense, which you would realize if you just used a bit of maths. Now, I go through this in my video about your magnesium experiments, where I make some recommendations on how to perform it properly. But back to your video.
Does that mean that the science part of what you were doing is wrong, or does it just mean that your model is wrong? Well, this is what our friend is about to demonstrate adequately to my audience, and I'm going to point it out.
Oh yeah, I do make a prediction, and I provide very convincing evidence that the prediction is wrong. Now, the experiment is perfectly suitable to conclusively show this, so the prediction must be wrong, and the prediction is based on a rigorous and logically correct development of your conclusion that a relative density disequilibrium causes a force. Now, this leads to two possibilities, and these are that your conclusion regarding the relative density disequilibrium is wrong, or the maths is wrong, and by extension, the laws of physics are wrong.
About to show that he makes a prediction based on his model that he attributes to me, and it doesn't match reality, and therefore he claims a debunk of me, which we all know that cannot happen when he's using his own bloody model. So let's see what happens now.
Oh yes, let's see how I debunk my own model. Oh no, there's something else first.
Oh yes. I've stopped it here because I want this screen to be seen. Where to start with this? Air pressure is given by the following formula. P equals... Look at what we have in the top, above this in this equation here. We have this little G bit, and in the ledger at the side he's put G as magical downward acceleration. I don't know if he's trolling me here.
Yes, I definitely am. Now, I would have liked to use a different formulation, but for some strange reason, this little constant keeps popping up. I wonder why.
Or whether he's just being satirical, or if he's just being a dope. But little g, there's a problem with using mathematics where you're trying to prove whether or not gravity exists.
Nope, once again, you are missing the point. I am not trying to prove anything like that whatsoever. All I'm doing on this slide is showing you where I got the values from. You know, it is that transparency bit I talked about earlier.
If you calculate for gravity, you are begging the question. That is another logically fallacious position to take. So let's have a look at the definition for begging the question. Any form of argument where the conclusion is assumed in one of the premises. Well, that's what he's doing. He's begging the question. He's literally assuming that gravity exists in his calculations. It's a form of circular reasoning. Shouldn't be doing this, dude. This is not science. This is called deception.
Now, really nice work, Anthony. By asserting that I'm trying to prove that gravity exists, you are building a straw man. You can do this so you can invoke a fallacy. You see, my point is not fallacious as the calculations are consistent with reality. See my prior bit about the limits of reification fallacies. But by misrepresenting my intentions, you allow yourself to claim that I beg the question and conclude that my argument is incorrect because it's fallacious. Oh yeah, and that latter bit is a fallacy in itself, known as the argument from fallacy. Seriously, you need to try harder.
Anyway, let's carry on. Oh yeah, there's a secondary part to that. This is the great thing about annotating, your work, so you don't forget anything. Little g, the acceleration due to Earth's gravity. Well, the problem you've got is if you're trying to test for the existence of Earth's gravity, you shouldn't be calculating for it as though it exists, because that should be your presumed cause in your scientific experiment, shouldn't it? That's your independent variable. You shouldn't be calculating for it, because that's begging the question. Logically fallacious reasoning, you should not be doing it. That's because you can't science, as per your name. Anyway, let's carry on.
And the final position, which is rho m of 0, and these correspond to the initial position being 1 meter above sea level and the final position being 1 meter below sea level. Oh shit, how did you not pick up on that mistake? Of course, the correct statement is at sea level rather than 1 meter below sea level. Really missed something there. We can now plug these values into our expression to get a value for the Rayleigh coefficient for this system.
So we can now plug these values into your model to see if this so-called Rayleigh coefficient that wasn't necessary in the first place
you can see my prior comment regarding this.
Was only done to support the assertion that you're doing science by mathematicizing the shit out of this, as per Einstein, was credible in some way. And we all know it's not. So there's no science here at all, but we're testing, or you're demonstrating how your model fails, and then trying to pin that on me because your model doesn't predict reality. Oh, this is called dishonest. I'm going to call this dishonest. This is not what I said, this is not what I did, and this is what you think I mean, and didn't do any science to debunk me. You are the antithesis of science, sir.
Now please, direct me to a point where I say anything other than my model based on your assertions not working. There are two possible conclusions to the test of this model, and the first is that your assertion is incorrect. The second is that all scientific theory is incorrect. Now, are you arrogant enough to accept the latter? But let's do a sanity check on our expression for the velocity at the...
A sanity check? There's no sanity in this video, sir.
Instant before the object hits the ground. First, we check the bracketed terms. If the difference between the medium's density and the initial and the final positions is 0, then there is no velocity, which makes sense. If the initial density difference is greater than the final density difference, then the square of the velocity is a negative number, which means that the velocity is in the imaginary plane, and this is unphysical, so this checks out.
Ah, right, so notice what he's doing here now. He's using, if v is imaginary, because it's in the negative velocity, then that's not real world, right? He's using that concept of imaginary against me in his model.
Once again, you missed the point. The fact that the velocity would be an imaginary plane actually supports your relative density disequilibrium claims.
I didn't make these claims. This is literally red herring, right? This is a straw man argument that I did not make. But he's saying that if this is a negative value, it's imaginary. Let's not forget the current science, according to Albert Einstein, since 1915, sir, more than 100 years ago, is mathematical in its nature. It's a mathematical construct. It doesn't exist in real world.
And by invoking Einstein, you are just throwing in a red herring, but fuck it, I don't really care that much.
It doesn't exist in real world. That makes it imaginary. And that's your current science for gravity. It's funny how you use the imaginary position against me or in your model that I didn't make any assertions of, but you ignore that your current science is imaginary. Isn't that a perfect illustration of a paradox? We'll call it the scientific paradox.
Oh, now I get it. You don't understand imaginary numbers, of course. Why am I not surprised? Also, you could have picked up on the obvious mistakes here. The mistakes are in the wording and the notation only. However, the error was not carried forward.
You just committed a logical fallacy. Again. No science, though. Again.
No science? Now, this is something called reductio ad absurdum, and it is a process to see if the models hold with expectations. It is an essential part in checking your predictions. Oh, and as a bonus point, this is also the process which you can use to show that Newton's law of universal gravitation is consistent with general relativity.
Anyway, let's carry on.
Finally, we see that the mass of the object is a factor. The square of the velocity is inverse proportional to the mass of the object. Now, this is problematic, as this suggests...
Well, this is only problematic in your maths, in your model that I did not do any assertions of at all. This is all of your construct, not mine. There's only a problem in your model, sir. There's a problem in your model, that's your problem because it's your model. It's not my model, is it? I didn't model anything. I did science. I manipulated an independent variable and showed a cause and effect relationship. The problem in your model, let's just be really clear.
Yep, this is a problem in the model that I developed based on your conclusions. The thing is that all the maths is based on physical laws. So either your conclusion, which forms the basis of the model, is wrong, or all the physical laws are wrong. Again, are you arrogant enough to choose the latter? Tests that lighter objects fall faster than heavier objects. So let's see if that is correct. Here are two half-liter bottles. The one without a label is empty and the other one is full. The bottles themselves weigh around 20 grams and the full bottle is filled with water. The end result is that the mass of the full one is roughly 20 times larger than the empty one. Now, according to the development of...
Right, so basically, this bit either... I don't know where that last clip's gone. Well, basically what he does is he drops the bottles and he shows that they fall at the same rate, and he uses that in some way to debunk me in some way. But the problem with this is the only bit of science that he's got in his video.
So, let me get this straight. You take umbrage with me taking a rigorous approach to developing a hypothesis and then testing it, but I thought that you liked science.
And from this bit of science, he concludes that it doesn't match his model that he's created, and then claims that this is somehow debunking me.
Oh, fuck it. I can't be bothered with the rest of the video, but as he couldn't be bothered with the rest of mine. In summary, Riley asserts that I'm trying to debunk him, but I'm not. I'm only building a model based on his conclusions and then made a prediction based on that model, which I subsequently tested. That is how science works. At no point do I assert that the model is his model. Yes, I make some tongue-in-cheek references to him, but I would not attribute the model to him because fuck it, it took too much work to allow him to take credit. Sleeping Warrior's little escapade just demonstrated how easy it is to step on his toes. Even in an attempt to help him develop his ideas, he gets huffy. I guess that it is because he doesn't like someone properly thinking about the nonsense he spouts out. Now, I will close with a personal message to Anthony. In science, we test ideas and subject them to scrutiny, and this may come across as harsh, but there is a mutual understanding that this is a productive approach. In reality, the treatment you have received through my videos is actually very polite when compared to the discourse that we participate in as scientists. Now, throughout my response, I've made it very clear that I was not trying to debunk you. Even though your relative density disequilibrium idea is nonsense, I wanted to take it seriously to see how far I could go with it. You would be surprised how far I actually went to make this happen. The definition of what I call the Riley coefficient is essential to the development of your model. Otherwise, your idea would have fallen down at the first hurdle. The bit that you didn't show is the definition of phi, which is a space-dependent acceleration gauge, which was also necessary to make the idea work. And it took me actually quite a bit of work to figure this one out. Now, I am not claiming that the model is correct. In fact, I am doing the opposite. But as you have said, I have only disproven the model that I developed. But as the model is based on known laws of physics and the only reasonable formulation of your relative density disequilibrium notion, we can conclude that either the laws of physics are incorrect or that the fundamental premise of relative density disequilibrium causing a force is incorrect. Of course, both could also be the case, but I know where I would place my bets. One really important mistake that you made is to assume that I was trying to debunk you, and as a result, you came out all guns blazing with a response to my video. In your response, you have demonstrated that you do not only struggle with science and mathematics, but also with words and paying attention. Think about things before you do them.